A very good afternoon to all the students. So today we'll be starting with the unit 5, which is based on correlation analysis. So let us look after the list of contents, that is the index. First we will be talking about correlation analysis, the introduction, types of correlation, scatter diagram, Kale-Pearson's coefficient of correlation, properties and interpretation of correlation coefficient, merits, demerits of Kale-Pearson's coefficient, Spearman's rank correlation coefficient. So now last time we had discussed about two concepts. One was about your correlation analysis and the next one was about your regression analysis. So you need to understand as to what is the basic difference between the correlation and the regression. So correlation basically tells us about the relationship between any two variables, whereas the regression analysis, it tells us about the relationship between the independent variable and the dependent variable. Next, let us understand the concept of the correlation coefficient. So normally the correlation coefficient, it is denoted by the symbol of small r, and it takes the values from -1, 0 to +1. So based upon these values, there are the different types of correlation. First one is the no correlation. So over here what happens is that r is equal to 0. Okay, so the correlation coefficient, it will be taking the value of 0, which means that there is absolutely no relationship between the two variables. Next is the positive correlation. So what happens in the positive correlation? That r will be equal to 1, okay, which is a positive value. Now what happens over here is that in a positive correlation, both the variables x and y, they move along the same direction. Either they will be increasing or they will be decreasing. Okay, so they need to move in the same direction. Can you think of some examples related to positive correlation? Okay, so basically we can take the example of age and height of adolescent students, school-going students. As the age goes on increasing, the height goes on increasing. Similarly, as the age goes on increasing, the weight also goes on increasing. So this is a perfect example of the positive correlation. The next concept is the negative correlation. So over here what happens is that r is equal to -1, it takes the negative value. It tells us that there is a negative relationship between the two variables x and y. So over here what happens is that the two variables x and y, they are going in the exactly opposite direction. Meaning if x is increasing, y will decrease. If y is increasing, then x will decrease. So we have over here different students from different specializations like arts, science and commerce. So respective to your junior college studies, you can think about different kind of examples from your particular stream, any stream. Okay, so let us take science for example. You can take up a formula which is inversely proportional. Okay, so for example, speed is inversely proportional to time. What is the formula? Speed is equal to distance divided by time. So over here what happens is, as the speed goes on increasing, the time goes on decreasing. As the time increases, the speed decreases. Okay, so this is a perfect example of your negative correlation, wherein the two variables we have seen, speed and time, they are going exactly in the opposite direction. So over here on the slide you can see the different scatter diagrams. Okay, so the first graph that is being given, you have the x-axis, you have the y-axis, and the different plotting of the coordinates of x and y has been done. So the first graph tells us about the strong positive correlation, meaning that both the x and y, they are going in an increasing order, in an ascending order, and they are closely related to the arc, which tells us that there is a very strong positive relationship between the x and the y variable. Next graph, if you see, is the weak positive correlation. Over here what happens is that the x and y, they are loosely related or they are scattered from the arc. That is the meaning of the weak positive correlation. The next you can see is a strong negative correlation. Over here if you observe the direction of the arc, it is going in the descending order. That means it is going from the y point to the x point. But x and y coordinates, they are closely related to each other, which is why it is a strongly negative correlation. Next you have the weak negative correlation. Over here what is happening is that the x and the y, again they are loosely related or they are scattered and they are going in the descending order, that is they are going in the downward direction. Next you have the moderately negative correlation. Again over here, moderately placement of the x and the y variables is what you can observe. And finally, we come to the last graph, which is about the no correlation. Over here, again, you can observe the x-axis, you can observe the y-axis, and these variables x and y, they have been plotted in such a way you can observe that there is absolutely no correlation between them, which is why they are completely scattered. So basically, what is a scatter diagram? It tells us that it shows the values of the x and y along the x-axis and along the y-axis and the respective coordinates. Next very important thing, students, we are going to discuss today is that we are going to discuss about the two different types of coefficient of correlation. First one is going to be the Kale-Pearson's coefficient of correlation, and the second one will be the Spearman's coefficient of correlation. So let us understand the first formula of the Kale-Pearson's coefficient of correlation. It is denoted by R is equal to n into summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x square n into summation y square minus summation y square. Here let us understand the contents of this formula. N is equal to the number of observations, as you people know. It can be also be interpreted as the quantity of the information. Then you have the summation x, that is the total of the first variable value. You have the summation y, it is the total of the second variable value. Then you have the summation xy, which is sum of the product of the first and the second value. Then you have the summation x square, which is the sum of the squares of the first value. And then you have summation y square, which is the sum of the squares of the second value. So these are the properties and interpretation of correlation coefficient and the merits and demerits of Kale-Pearson's coefficient. So this we will be discussing towards the end of the chapter. Now, my dear students, it will be my sincere suggestion that your first priority while solving these final exams would be that you should focus on solving the numericals first, because they are going to be more scoring, and then later on, if time permits, you can go for solving the theoretical this thing. Again, this is my suggestion, and finally decision is yours. Okay. Now, the numericals, let us see. You can see that calculate the correlation coefficient of the given data. Okay. So, as last time also I had told you that whenever you will be writing in your final exams, you need to properly write the numerical format, like given, to find, the formula, the solution. So, this is certain things that you have to follow and do not miss the steps. Okay, so this is one suggestion that I would like to give you. Now over here, if you see the x variable values that are being given to us are 50, 51, 52, 53, 54. Then the y variable values that are being given is 3.1, 3.2, 3.3, 3.4 and 3.5. Now let us start solving. So n is equal to what? The quantity of information or the number of observations. How many number of observations do we have? 5, right? So that is the reason n is equal to 5. Then you have the x values. In the horizontal row, you have the y values. Now, one more important hint that I would like to give you, my dear students, is that many times those students who have not come from a mathematics background, or those who are not that much confident in the statistical background, or those who have not studied mathematics or statistics before, they tend to do a mistake of memorizing the numericals. So that is something that I would like to tell you, is that do not memorize the numericals. Please remove the stigma of memorizing the numericals. Okay, so what is important is that from solving point of view, understanding the formula is very important, and then you have to see what kind of contents do you require while solving that formula. So now you know the formula. You will be requiring the summation of x, summation of y, summation of xy, okay, and n value. So simply those values we are going to put in this chart, and that is how you are going to prepare this chart. There is absolutely no requirement for you for memorizing this chart or this table. Okay, now let us go to this chart. X, you have all the 5 variables, y, all the variables are being given. Next, you have the product of x and y. So let us take, for example, 50 into 3.1. What is the value you have got over there? Is 15.5. Okay, accordingly, you will be finding the product for all the variables x into y. Next you have to do is x bracket square. So you have the x value, which is 50, and you have to take its square, which is 2500. Then you have the value of y, which is 3.1. You take its square, y square is equal to 9.61. Similarly, you will be calculating for all the values of x and y, and automatically this chart of yours will be prepared. Next, you have to find out the summation of x. Summation of x is 260. Then summation of y is 16.5. Summation of xy is 859. Summation x square is 13530. Summation y square is 54.5. Now that you have all the required constituents in the formula, you have to simply substitute all these values in the formula for Kale-Pearson's coefficient of correlation. And after solving the formula, you get the answer as r is equal to 1. Now, my dear students, please understand that whenever you are solving these numericals based on correlation analysis or regression analysis, it is not only sufficient to only find out the answer and leave it over there. What is important is that you need to write the interpretation as well, because the interpretation in a 10 marks question, it carries at least 3 marks. So that is the significance of writing the interpretation. So please understand, now that we have got the values r is equal to 1. So now we had seen the 3 different types of correlation, 0, -1 and +1. Now looking at this particular answer, it is very clear this is a perfect example of a positive correlation coefficient. This is going to be your interpretation for this numerical. Clear to everyone? Fine. Next, you have the calculation of the correlation coefficient. Again, for the given data, we are going to substitute the values of x, we are going to substitute the values of y. Again, over here n is equal to 5, and you have put it into the formula of Kale-Pearson's correlation coefficient. Over here, what value you are getting is r is equal to 0.84. Okay, so now it is very important to understand how you are going to interpret these particular values. If your value carries a negative number like -0.3 or -0.4, it is very evident that you will write the interpretation as there is a negative correlation between the two variables. If the value is r is equal to 0, then you can say that there is no correlation. Now, for the positive correlation, everyone, I want you to pay attention over here. It is very important. For the positive correlation, it is going to take the values from 0 to 1. But how you are going to interpret it, right? So, if the value of r comes out to be between 0 to 0.5, like 0.3 or 0.4, up to 0.5, you are going to say that it is an example of a weak positive correlation. Next, if the r is equal to 0.5 to 0.6, you are going to interpret it as a moderately positive correlation. If the r's value is between 0.6 to 1, so it can take the values between r is equal to 0.6, 0.7, 0.8, 0.9 up to 1, then you can say over there that yes, there is a strongly positive correlation between the two variables of x and y. So this is how you are going to write down the interpretation of this. Now, we have completed the first type of correlation coefficient, that was your Kale-Pearson's rank correlation coefficient. Now, let us move on to the second type of correlation coefficient, that is the Spearman's rank correlation coefficient. So, what is the formula? Rho is equal to 1 minus 6 into summation di square divided by n into n square minus 1. So, over here the rho symbol, it denotes Spearman's rank correlation coefficient. Then the n, as usual, it denotes the number of observations or the quantity of information. Then you have di. So what do you mean by di? Di basically talks about the difference between the two ranks of each observation. Now let us see the interpretation. If the rho is equal to +1, then there is a perfect association of rank. If rho is equal to 0, there is no association between the ranks. If rho is equal to -1, there is perfectly negative association of rank. Next, let us see a numerical based on the Spearman's rank correlation coefficient. Over here, you have to consider the score or the marks of 5 students in mathematics and science that are being mentioned in this particular table. So, the first column is about the students A, B, C, D, E. The second column is maths and the third column is science. Now all the steps over here are being mentioned as to how you are going to solve about it. Now if you see the formula of rho is equal to 1 minus 6 summation di square divided by n into n square minus 1, you can observe that the constituents that you require in the formula are basically di square, and for that you have to calculate the d. For that you need to have the difference between the two ranks of mathematics and science. Now how is it that you are going to find out the ranks? That is what we will see. So the first column talks about the students. The second column over here, you can see the mathematics marks are being given to you at random. No particular sequence as such is being mentioned over here, either in the ascending order or the descending order. Okay, so you have the mathematics marks like 35, 20, 49, 44 and 30. So how you are going to rank it? You have to rank it strictly based on the descending order. So if you observe these marks, which is the highest value given over here is 49. So for 49, it is the highest value, and so you are going to assign rank 1. The second highest value is 44, you will be assigning rank 2. The third highest value is 35, so you are going to assign the rank 3 and so on. That is how the ranking for the mathematics column will take place. The next column is science. Again over here you will see the highest value is 48, so the rank will be 1. The second highest value will be 45, rank 2. The third highest value is 39, which will be the rank 3 and so on. Now, the most crucial step is finding the column of D. D is nothing but the difference between the rank 1 and the rank 2. So, over here you will be having the values as 5 minus 3, 2, 5 minus 4, 1, 3 minus 1, 2 and so on. Please understand that whenever you are calculating the D over here, you are calculating it as per the absolute value bracket that we had talked about in the unit 2. Right? So over here, even if the value is negative, since you are putting it into the absolute value column, that is why automatically it will be getting converted into a positive value. So this is how you will be calculating your D. Furthermore, the next column is about your D square. So you will be doing the square of the column D, which will be 4, 1, 4, 1, 4, and then finally the summation 14 is what you have to put into your formula. Now that you have all the values that you are going to require in your formula, you are going to enter all these values, that is rho is equal to 1 minus 6 into summation di square. So now we have just calculated what is the summation di square, it is 14 divided by n. What is your n? That is 5. So 5 into n square, that is 5 into 5, 25 minus 1. Okay, so this is what we have done. After putting the values, what we have is 6 into 14 divided by 5 into 25 minus 1, that is 0.3 is the value that you are getting for the Spearman's rank correlation coefficient of rho. Now, you have to tell me as to whether it is weakly correlated, it is moderately correlated or positively correlated. Yes, correct. Since the value is going near 0, it means that the value is lying between 0 to 0.5. which indicates definitely it is a positive correlation, but whether it is a weak correlation, whether it is a moderate or whether it is a strong. So since the value is going near the 0, that is between 0 to 0.5, we are getting the value of 0.3, and hence we can say that there is a weak correlation between the two ranks. Okay, clear to everyone? So this is the way today that we have seen how you are going to solve the concept of correlation analysis. How is it that you are going to measure the correlationship between the two variables? And the only way to measure the relationship between the two variables x and y, and to understand and measurement of these correlation of x and y, is by using the two different types of correlation coefficients that we have. First one is the Kale-Pearson's correlation coefficient, which is denoted by small r, and the second one is the Spearman's rank correlation coefficient, which is denoted by rho. Okay, so I want you people to go home and practice this. Next time we will discuss about the covariance concept. Okay, so thank you all. Have a